SSAS data mining. Last night I hopped onto the internet to see what the weather forecast was going to be for today. And it said it called for scattered showers all day long. Well, how did those weather people know what it was actually going to look like today? Well, they made some predictions based on patterns that they've seen in the past. So when they detect certain air pressure patterns, they can determine what the weather is going to look like. Well, with SSAS data mining, we can do something similar. We can look at historical data and look at different attributes of that historical data. It's all going to be inside of a table. And then we can apply that to current data to determine whether or not something's going to happen. So in this nugget, we're just going to talk about some basic concepts dealing with data mining, and then we'll look at some mining models. A mining model uses an algorithm to determine different patterns. So our focus is going to be on decision trees, as well as clustering, and another algorithm called naive Bayes. I'll show you how to implement these mining models and then interpret the data. So in this nugget, I'll show you how to apply those mining models to our current data, and in particular, we're going to look at a couple tables dealing with bike purchasers. Let's take a look at the different steps for implementing data mining. The first thing we want to do is define our problem. You want to be as specific as possible. In our specific example, we are going to have a table called prospective buyers, and we want to determine which of those people are probably going to purchase a bike. That table consists of several columns that contain information such as the age, gender, number of children they have at home, and the number of cars that they own. Before you do any data mining at all, you want to implement the second step, which is to prepare the data. That involves cleaning your data. For example, you want to make sure that any missing values that need to be populated are actually populated. You also want to check for the validity of the data. For example, if it shows that somebody's birth date was back in year 300, that's probably not accurate data, and you'll want to remove that value. Then you want to explore the data. It's a good thing to be familiar with the different columns and what they mean. And what you can do is just go into your data source view and right-click and explore the data just to get a general feel of what the spread of the data is. The fourth step, you're going to build a model. What you'll need here are two sets of data. You'll need the training data, which is used to build the model, and then you'll have the testing data, which is used to check the accuracy. Sometimes the training set and the testing set are going to come from the same table. When you're building your model, you can actually have several models. For example, we're going to have a decision tree model, as well as clustering and naive Bayes. Once you build that model, then you're going to explore it. You can visually see, for example, how data is clustered together, or you can look at your decision tree model and see how things pan out as far as what attributes are related to other attributes. And then the last step is you're going to deploy the model. After you deploy your model, you can then see the predictive behavior. So in our example, we're going to build 3 models that are based on a particular table that contains historic information, and then we're going to look at predictive behavior on the prospective buyers table. Now, we've talked a little bit about algorithms. I want to talk a little bit more in detail of what some of the provided algorithms are. You'll see that out of the box we have these different mining models, and there are also mining models that you can plug into SQL Server, but let's just cover these right now. When we talk about discrete and continuous columns, what we mean is that continuous columns can have a range of values, whereas discrete are going to be certain values. An example of that might be gender. A gender for a person is either going to be male or female. So that is discrete. Or another example of discrete might be employee title. There's going to be a handful of titles that are valid. Now, an example of a continuous column would be maybe the age or a salary of an employee. Well, a decision tree can be used on both discrete and continuous columns. Essentially what we do is we take our data and that forms the root node, and then that root node gets split off into different paths. For example, we might start off with everybody in our table in the root node. And then we're going to split that tree off. For example, we might group people together by age, and then we might split it off again based on the number of cars that are owned. Eventually you end up with leaf nodes, in other words, nodes that don't have any children, and those nodes will have similar characteristics. Then we have clustering. With clustering, all we're doing is grouping cases into a data set of related attributes so you can visually see them. You can also see which clusters are similar to other clusters. Naive Bayes performs conditional probability between input and predictable columns. So we're going to do examples of these first three mining models. Let's talk about some of these other mining models right here. Time series is going to predict continuous columns, and it determines the forecasts that a model will make. An association algorithm makes recommendations. An example of that, we might relate products to other products. I'm sure you've been to a website where it says, okay, you've made these purchases, you might also like these products. It makes recommendations. Then we have sequence clustering. Sequence clustering is going to find events that are linked by following paths, otherwise known as sequences. An example of that might be the click paths on a website. For example, if a lot of users go from page A to page B, we can make a prediction that other users will do the same thing. We have neural network. This is a very intensive algorithm. It's an analytic technique, and it's just going to predict new observations from other observations after executing what we call a learning algorithm. Logistic regression is a variation of neural networks. It's a little bit simpler and not quite as intensive on the system. And then last we have linear regression. It's simply a variation of a decision tree, except it never splits into different nodes. Now that you understand the basic concepts of how data mining works, let's go ahead and actually implement an example. Right now I have my Business Intelligence Development Studio opened up, and I'm going to create a new project. This will be an analysis services project. So right here, and I'm just going to call this my mining, and then we'll hit OK. Now, just like we did earlier with our analysis services, we have to have a data source and then create data source views that are based on that. So we're going to make our data source be dependent on the Johnson Adventure Works DW 2008. Johnson is just the name of my server. And then we'll go ahead and hit next. And I'm just going to use the service account. And our data source name, I can just stick with the default. You can change it if you want to. I'm going to now create a data source view that's based on that. And really, I'm just interested in two tables. Here, we'll go ahead and click on Next. The two tables I'm interested in are the vTarget Mail. vTarget Mail is a table that contains historic information on who bought bicycles. For example, it contains columns such as age, number of children at home, gender, things like that. Now the other table we're interested in is the prospective buyer. Now this is just a list of prospective buyers, and it has information such as their age, number of children at home, and so on. So once we process our models on the vTarget Mail, then we can run it on our prospective buyer and see who our prospective buyers are. Which ones should we really target? Okay, so now I'm going to hit Next. And let's just stick with the default here for the name. And we hit Finish. So there it is right there. Now, let me move this over a little bit. Under Mining Structures, I want you to right-click. We're going to create a new mining structure. This is from an existing relational database or data warehouse. And we're first going to implement a decision tree. We're also going to do a naive Bayes model as well as Microsoft clustering, just so you can see how different models work. Okay, so there's our data source that we created, or our data source view. And let's focus on this column here that says case. Case simply means which of these tables contains the historic information. Okay, so it's target male, and then we'll hit next. And we have 3 columns here. The third one is the predictable column. So what it's asking us here is, out of all these different columns in the table, what column are we trying to predict on? Well, there's this one column called bike buyer, and its value is either going to be set to 0 or 1. If the value is set to 1, it means that that person purchased a bike. If it's set to 0, they didn't buy a bike. Okay, so as soon as I click on predict that, notice that this is no longer grayed out. I can now click on suggest, and what this does is it just samples the data, and it looks at the other columns in the table that correlate to that column. In other words, it looks like age is a pretty high correlator. Okay, so then we can go ahead and hit OK. So you can check more columns as input if you want to. For example, if I want to check on here, maybe whether they're a house owner. Maybe I want to see if there's a correlation between number of cars owned and number of children at home. My guess is that if somebody has 8 children at home, they probably don't have much time for biking. Okay, so then notice that for the key was automatically determined because customer key was the primary key. So that was populated for us. Now there's this thing that we can do called drill down. Once we process our models and see our results, we can actually drill down and see the detailed information, for example, on our bike buyers. So if I want to allow for drill down, I can check extra columns right in here. For example, maybe I want to include their last name, maybe their first name, email address, and birth date. Maybe we want to send them a mailing on their birthday. Maybe also their address information. Now I can hit next. Now, right here it says detect continuous or discrete for numeric columns. In other words, if the column is numeric, is it going to be a range of values or is it going to be distinct values? So we can just hit detect on there, and it does a pretty good job of determining that. The percentage of data for testing, if you make this 100%, you might really kill the system. Let's stick with the default of 30%, and you can also cap out, put a ceiling on how many cases you want to test, because if you've got millions of records, you really don't want to pound the system. Our mining structure name, I'm going to keep that as is, and I will call the mining model name, I'll call this decision tree. Important here, let's click Allow Drill Through so we can see the detailed information. Now I hit Finish. At this point I can click on Mining Models right here, and you'll see that this is the structure of my table. Here is the decision tree mining model. I can create more mining models if I want to. In fact, I can just right click on here and I'll say New Mining Model. Maybe I'll call this one Naive Bayes. We'll talk about that algorithm in just a moment. And you'll just get a warning saying, you know what, the age column is going to be ignored, and we'll just say yes to that. And then we can add yet another mining model on here if we want to. Maybe we can do clustered. So now we have 3 different mining models. If we go into our mining model menu right here, we can say Process, Mining Structure, and All Models. Yes, we want to go ahead and build and deploy the project first. So this might take a few minutes. It really depends on how many models you have going on and how many records, as well as the spread of data. Make sure, you'll see at the bottom of your window here, go ahead and click on Run to kick it off, and just give it a few seconds. Almost finished here. Okay, it is finished. So let's hit close and then close again. Okay, so these have been processed. Now what? What can we do with this information? Well, let's click on this third tab here. And what this does, I'm going to move this over a little bit. When we're looking at our
decision tree mining model, you'll see that we've got this nice little tree view. I'm going to move this up a little bit more. And you'll see that on the very left-hand side it says all, and if you just let it hover over like that, you'll see that we have a total number of cases of 17,484. And as far as the number of bike buyers out of all of those, looks like we have, you see where it says the number 1, we had 8,618 people who bought a bike and 8,866 who did not purchase a bike. So we're seeing all this information, and this next level here, it's dividing all of these people into different ages. So remember earlier I said the most important factor in who purchases a bike is age. Well, that's what it's dividing these people by first of all. Once it's divided by age, then it divides by number of children at home and so on. What's important here is we want to focus on the people who actually purchased a bike. So under background, instead of saying all cases, we want to focus on number 1, which are the people who purchased a bike. Another thing I want you to notice is all these different rectangles are varying shades of blue or purple. The darker the color, the more concentration of bike buyers there are. For example, here's pretty dark blue. Number of cars owned equals 0. Total cases equals 268. Wow, there are 234 who purchased a bike and only 34 who did not purchase a bike. So it's pretty safe to say that if somebody is under age 35 and they don't own a car, pretty good chance that they will purchase a bike. You can also play around with this as far as the default expansion. If you want to expand this tree as many levels as you want, you can do that. Remember a minute ago I mentioned how we have drill through, so you can choose any one of these nodes that you're interested in and you can see the detailed information here. For example, if I'm interested in this node right here, I can click on it, say drill through. Maybe I'm interested in both the model and the structure columns. So now I can see all this data in here. I see even their customer key, I see whether or not they're a house owner and so on, even their address and email. Notice also that there's not only this tab for the decision tree, but there's also this thing called the dependency network. Okay, so here we have in the very middle, bike buyer. And the factors that really participate in this, whether or not somebody's going to buy a bike, is their age, number of children at home, house owner, and number of cars owned. And you'll see that there's this little slider here, and we adjust this to show only the strongest relationships between nodes. So if I pull this down a little bit, you'll see that all of a sudden house owner flag disappeared, or the arrow is gone. And as we drag this even further, number of cars owned disappears, and so on. So yes, indeed, the number 1 factor is the age. Okay, well that was our decision tree. Let's take a closer look at our naive Bayes model. Now, what you see here looks very similar. Once again, you have this slider. What I'd like to do is focus more on this second tab here called Attribute Profiles. So they give us here a legend, and what's interesting about this is that we can change the scale of our histogram. For example, if we say a histogram bar is equals 8, then we have a max distinct values of 8. I'm going to set this to something smaller like 4. So the way we read this is, here we have 0, which represents the non-bike buyers. Here is 1, which represents the bike buyers. So if I hover over this, which is the bike buyers, so it looks like the percentage of bike buyers that have 2 cars is about 28%. So you can just hover any of these and extract that information. For example, here, number of children at home. For the bike buyers, it looks like a large number of them have no kids. Okay, so about 63% of them had no kids. We can also look at attribute characteristics. We're interested in the bike buyer, so we're going to focus in on that. And the probability that the number of children at home is 0 is about 63%. The probability that a bike buyer is going to own just 1 car is 29.6%. Now, attribute discrimination. Let's take a look at that. Here we have in our drop-down only one choice, whether or not they're a bike buyer, and we're comparing two values. So value 1, let's change that to 1, and value 2 is all other states. Okay, so in other words, this column here represents the bike buyers, this column over here represents the non-bike buyers. So the number of cars owned equals 0. That definitely is 100%. Now let's talk about the third model, which is the clustering. So we'll go right here, and you'll see that we have all sorts of clusters here, and they're just given generic names. And there's this drop-down called shading variable, and what we're interested in are the bike buyers, so select that. And the state that we're interested in is 1, in other words, the people who actually purchased a bike. Now, if you hover over any of these clusters, you'll see that there's a percentage number. So this is 72%. In other words, in this cluster, 72% of the people purchased a bike. In this cluster, 59% purchased a bike, and so on. So this right here, this cluster, has the highest percentage. So I'm just going to right click on here, and you can actually rename your clusters. I'm going to call mine high, and then I'll hover over a couple of these until I find the lowest one. So this is 36%, this is 35%. Looks like this one is the lowest, so we'll right click on there and we'll just call that low. And then we can take this little slider, and you'll see that some of these lines are disappearing. So we're seeing these strong associations between clusters. So I'm going to move this actually up until I see a link between high and some other cluster. Here we go. So it looks like there's a relationship here between high and this cluster here and high and that cluster there. What you can do now is select a different shading variable. For example, if I say number of cars owned, you'll see that for cluster number 1, 43% own 0 cars. Remember, there's that strong relationship there. If I look at cluster 9 here, just hover over it, 19% of the people in cluster 9 own 0 cars. Okay, now let's take a look at cluster profiles. Here we have variables, so we have age, bike buyer, and so on. It also shows the different states and then the different clusters. So here we have the high cluster that we defined. So for that particular cluster, it looks like 724 out of 2,102 actually bought a bike. A good chunk of those are house owners, and almost all of them do not own a car. And if we scroll down a little bit further, number of children at home is 0 for most of them. If we go the other way and take a look at our low cluster right here, looks like a good chunk of them are homeowners as well. And the number of cars owned is 2. I mean, that's the highest percentage at least. And the number of children at home, for the most part, that's 0. Then we can take a look at cluster characteristics. You'll see here we have this drop down here, so we can choose everybody, or we can hone in on a particular cluster. So if I focus on the high cluster, there's a pretty high probability, 99% probability, that the number of cars owned will be 0. There's also a pretty high probability, about 83% of these people are homeowners. And for 79.5% of them have no children at all, and so on. So you can see that all these different attributes get smaller and smaller. And then the last thing we can take a look at is the cluster discrimination. I'll move this over here a little bit. Okay, so what you can do is take a look at 2 different clusters. So if you want to focus on the high cluster and then look as a comparison to the low cluster, you'll see that for age 50 through 97, that definitely favors in the low cluster. In other words, most of the people in that age range are going to be in that cluster over there. As far as 28 through 49-year-olds, most of those are going to be in the high cluster, in fact, 100%. So it's a quick and dirty way of just seeing how the clusters fare with different attributes. Okay, great. So we talked about 3 different mining models. Which one is the most accurate? Well, the best way to tell that is to click on this tab that says Mining Accuracy Chart, and then make sure that you select the tab that says Lift Chart, and you should see something that looks like this. You'll see a blue line that goes straight across like that, and that's what we call the ideal model, and then you'll see other lines representing your mining models. So the line that comes closest to your blue line is most likely going to be the most accurate model. So if I move this over here, you'll see that the pink line is closest, so that relates to the decision tree. If I move that over just a little bit more, you can see that it's given a score. So it has a score of 68 as opposed to 62 or 63. Now that we've looked at the different data mining models and we've determined that it's probably going to be the decision tree that's going to be the most accurate, let's go ahead and test that against our prospective buyers table. In other words, we're going to take our model and apply it to our prospective buyers table and determine which people are actually going to purchase the bikes. Okay, so the way we do that is we go to our mining model predictions. And what we see here is the mining model right here. We have age, bike buyer, customer key, and so on. And our case table is prospective buyers. Before we do anything there, before we select that table, let's just look at it in our data source view. So we can double click on here, and you'll see that there is not a column in here called age. However, there is a column in here called birth date, and so we need to create our own calculated column which takes the birth date and determines how old that person is. So let's just go ahead and right click on there and say new named calculation, and we'll call this calculated age. And we'll just, for the description, we'll say age based on birth date. And so here we'll just put in our expression. We're using the year function and then the getDate function, and we're doing a little bit of date math here. We're subtracting the year of the birth date and so on. This right here is simply a case expression returning either a 0 or a 1. So now that we have that calculated column right there, we can make sure that it's actually working. We can right click on prospective buyer and say explore data, and if you scroll to the very last column, here is our calculated age. Yes, it looks like it's pretty accurate. So now that we have that, I'll go ahead and save it, and then I'll exit out of there. We'll exit out of there as well. And we're going to select our input table. So our case table is our prospective buyer, and here we have our calculated age. So what we can do is draw a line between age and calculated age. Right here we have bike buyer. There is not a bike buyer column in here, but there is the unknown. That's what we're trying to find out, is whether the prospective buyer will be a bike buyer or not. Now our next step, you'll see down here that we have some empty rows that we need to populate. So what we need to do in here is, first of all, from this drop down, select prediction function. And what we're trying to find out is the probability that something's going to be true. So predict probability, and you can leave the alias blank if you want to. You can leave the group blank and or blank, but the criteria argument, it's going to be some kind of argument right there. Actually, you can drag and drop things. I'm going to take this bike buyer and drag it right there, and you'll see now that it's showing up as decision tree.bike buyer. Let me make this a little bit wider. Then the next thing you want to do is under here, you're going to select the decision tree mining model,
and stick with bike buyer right there. And the criteria or argument, you want to look for the people who are going to be bike buyers. So if that is equal to 1, okay. Now if you were looking for the people who are not purchasing bikes, you would say equals 0. Then the last thing you do in here, you're going to have the prospective buyer table, and you have your prospective buyer key, and let's find out some other things as well here. Let's find out the names and the email addresses of those people who are probably going to purchase a bike. So we'll create a few more rows in here. Here we have a prospective buyer table, and we'll just drag in here the last name and the first name. Here, let's just get rid of this row right here. Okay, so last name, let's drag the first name as well. You can just drag it just like that. And let's also grab the email address. And you can go further with this if you wanted to include the address, information like that. Now you'll see here that we have different views here. Right now we are in the design view. And what we can do is look at the result view. And what we get here are the email address and name of the people who are probably going to purchase a bicycle. The leftmost column here is the probability that they're going to purchase. And bike buyer right here, you'll see it's 1 all the way through because that's all we're interested in. And this is their unique identifier. So in the real world, you would take this information and maybe create a mailing list or do an email blast to these potential buyers. And that is your primer on using data mining with SQL Server. Let's review what we learned in this nugget. We first of all talked about the purpose of data mining, which is to predict some kind of behavior based on past behavior. Remember, before you prepare your models, you're going to need to clean your data and also explore the data so you're familiar with what's in your tables. Once you've cleaned that data, you're going to create your data mining models. We covered several different mining models, but our focus was on decision trees, clustering, and naive Bayes. We determined, using the lift charts, that our decision tree was going to be the most accurate. Once we deployed our mining model, we applied that decision tree model on our prospective buyers table. And our end product was that we had a table of our prospective buyers. In our particular case, it was the age of the prospective buyers as well as the number of cars owned that determined whether or not they were going to purchase a bicycle. Well, I hope this has been informative, and I'd like to thank you for viewing.